Algebra 1, you learn the basics of numbers, like how to manipulate an equation. And then geometry, you're taught in terms of infinity. So now here in Algebra 2, we're looking at numbers and their solutions in terms of infinity. So let's kind of walk through some progression questions that you've already studied. Ready? Yes. So far, we've studied equations with only, I'm drawing with the wrong pen, with only one variable. How many solutions did we find for equations with one variable, like this example shown? If you were asked to solve this, how many answers would you get? 1. You'd subtract 4, you get 6 is equal to 2x. You'd solve and you get x to equal 3. That's one solution. You solved a lot of those in Algebra 1. Then, as you increased in your understanding, you could then understand numbers like ones that showed up in inequalities. We did this in our most recent unit. We studied inequalities. You might have had an answer like x has to be greater than 3. If you were asked what are all the solutions greater than 3, how many solutions are there? Infinite. You could give me 3.111, 3.6, 3.8. You could keep going, and obviously numbers bigger than 3 as well. Now, we looked at how to write the answers in interval notation, but really, if you're looking at it in a picture format, we showed the reader what the solutions would look like using a structure you learned in geometry. What is that structure? A line. And in Algebra 2, it's a number line. So you would have an open circle at 3, and then you would show the reader with shaded values that it could be anything bigger than 3, like 4.5, 5.5, 5.8, and it just keeps going forever. So visually, you showed the answers on a number line. Now, for the remainder of Algebra 2, we are going to study solutions to equations, this is really key, with more than one variable. For example, here's an equation that has two variables, x and y. And if you're asking how many solutions are there to this equation, well, let me give you some examples to help you think through this. So I'm going to go ahead and, I don't know why that's not working. I'm going to copy this over here. Y equals 2x plus 5. And I'm going to give you some solution examples. How many variables do you see there? 2, x and y. So if I'm going to give you a solution, I have to really give you two numbers. Let me give you an example of one solution. 0, 5 is a solution to this equation. Let me give you another solution. 1, 7. Let me give you another solution. 2, 9. I could give you a negative value like -1, 3. Let me give you another solution. Like if I give you -2, then I would have -2, 1 would be another solution. On your own, see if you can create another solution to this equation. Remember, a solution is a value that makes the equation true. Since I have an x and a y, the only way I can make this equation true is if I give you two values. So again, on your own, see if you can provide one additional solution that I did not give you. After you have it, or maybe you're still discovering the pattern, turn to your partner and share with them what solution did you provide, if you were able to think of another one. Olivia, I'm good, I can hear you.
I'm sorry. Would 5 work?
5, and then you'd have to show the other number. So what would the other number be?
-5? Yeah, I don't know.
So if you plug in -5, the key here is whatever number this is representing the x. So if I plug in a -5, then 2 times -5 is -10, plus 5 would tell me that -5 would be another.
Okay.
All right, guys. My partner walked me through the solution -5, -5. Did anybody think of a different solution? Caroline? 413, that works? Freddie, do you have another one?
3 and 11.
3 and 11, perfect. Michaela, do you have another one? -3, -1, perfect. Okay, guys, for those people providing solutions, what are they doing to find the solutions? All of these are good solutions. What are they doing with this equation to determine the solution? Okay, somebody who answered. Caroline, what did you do to find the answer to that equation? Nice. Plug a number in for x first. So like 2 times -1 is -2, plus 5 will give me the answer for y. So if you have 2 variables, the solutions to the equation is going to contain 2 numbers. You can plug in anything for x, and you have to have the corresponding value come out for y. How many values could you potentially have listed? How many solutions are there? Could you plug in fractions? Could I plug in like 1/2? Yeah, you get 2 times 1/2 is 1, 1 plus 5 is 6. Could I plug in negative fractions? Could I plug in, how many numbers could I plug in? Infinite. So how many solutions are there? Infinite. And this is the key. Infinite values of x were represented on a number line. Infinite values of x and y are represented on the xy coordinate plane. And this is kind of key. This is an answer as well. I copied this exactly from your book. The graph of an equation in x and y is the set of all points on the xy plane that satisfy the equation. That just means makes the equation true. Now, if I was to show the reader the infinite amount of solutions, I would plot all of these points, like 0, 5, like -2, 1, like 1, 7, like, what else did I have here? 2, 9. I had 3, 11. I think somebody gave me that one. 4, 13 goes off my graph, but I could write it. -5, -5. And you guys might have already come in with some prerequisite knowledge. You might already know that this is a linear equation. You might have already studied some of its characteristics, like its slope and its y-intercept. But the key in Algebra 2 is knowing that all of those points are solutions that make the equation true. And if you list all the solutions to an equation in x and y, you will always create some type of curve. So in this case, that curve was a line because this is a linear equation. You're going to see curves like a parabola. You're going to see curves like a V. But if you don't know the equation's graph, you can just plot as many solutions as you can think of, or in other words, plot as many points as you can find. All right, so that's really where we're going to start today. The graph of an equation is a curve. That last one was a line. To graph an equation, this is key. If you're working with your homework tonight and you don't know what the graph looks like, plot as many points as you can until you can connect them with a smooth curve. Sophie. Yeah. So let's go ahead and let's start with this first one. This first one, I've told you that it's a linear equation, but let's say we didn't know that. If I didn't know that, I would just plot x and y values. And most often it's easiest to plot them using a table. What would I have to do with this equation first before I could use a table? Allison? Good, get y alone. Get y alone. So I would subtract 2x, and that would give me -y is equal to -2x plus 3. Is y by itself? No, what do I have to do? Good, divide by -1, and you guys know to keep an equation balanced, we have to divide everything by that number. So I would have y is equal to 2x minus 3. Now that I've done what Allison said, it's way easier to plug points into my table. And I'm going to tell you guys, for all the graphs we look at, because you are usually graphing around the origin, good points to plug in would consist of like -2, -1, 0, 1, and 2. Could you have plugged in other numbers? Yes, but I'm going to tell you for today's purposes and for tonight's homework, this usually will bring about the graph that you're trying to find. So if I plug in -2, where do I plug it in? In for x. So I would ask -2, I'm going to plug that in, 2 times -2 minus 3. What comes out for y? So what is -4 minus 3? -7, which means I'm going to plot the solution point, -2, -7. It's an answer for this equation. So I would plot that, -2, -7, plug in -1, and I would have 2 times -1 minus 3. So I'll plug -1 in. -2 minus 3 would give me -5. And so I have the point -1, -5. And I'll plot that. Plugging in 0, I would have 2 times 0 minus 3. 0 minus 3 is -3, so I'm going to plot the point 0, -3. Plugging in the number 1, I would have 2 times, okay, I don't know what just happened there. 2 times 1 minus 3, which would give me -1. So I have the point 1, -1. And plugging in 2, I would have 2 times, I don't know why it keeps doing that. 2 times 2 minus 3. My gosh, what's going on? Would give me +1. Okay, if I didn't see a curve coming about, I would keep plugging in numbers until I found the graph. Are you guys comfortable with the curve though? What's happening here? It's a straight line. So if we connect these points and show that they keep going, we're able to show the reader the infinite amount of solutions to this equation. The key to know for tonight's homework, and really for future reference, if you have just a y and just an x in an equation, the graph is going to create a line. So I would just say the graph creates a line. I know many of you already know a lot of data about lines, but I'd say for tonight's homework, pretend you don't know about slope-intercept form or any of the others. Just use a table to identify solutions. All right, let's take a look at another type of equation. Sketch the graph of the quadratic equation, y equals x squared minus 2. This one is already solved for us for y. So we would just try to obtain the curve by using the solution points. So I would list an x and a y. And again, good numbers to use for this lesson are like -2, -1, 0, 1, and 2. And we plug them in for x of the equation. So plugging that in for x, I would have -2 squared minus 2. What's -2 squared? 4. What's 4 minus 2? 2. So I have the point -2, 2. And I would plot that. Plugging in -1, I have -1 squared minus 2. What is -1 squared? 1. What's 1 minus 2? 1 minus 2 is -1. Good. So I'd have -1, -1. And I'd have to plot that. Plug in 0, and I have 0 squared minus 2 would give me -2. So I have the ordered pair 0, -2. Plugging in 1, I'd have 1 squared minus 2, which would leave me with 1 minus 2, which is -1. So I'd have the ordered pair 1, -1. And plugging in 2, I'd have 2 squared minus 2, which would give me 4 minus 2, which is 2. And so I have the ordered pair 2, 2. 2, 2. Now, if you didn't see a curve coming about, you would keep plotting points. Like if I didn't know what was happening between those 2 points, I could plug in an x value of 1/2. I could plug in an x value of -1/2. But I think some of us have seen a quadratic before. Do you know that it's going to create this U shape, or can you see it at this point? Okay, that's another equation to really kind of have in your tool belt before starting tonight's homework. If you have a y in an equation with an x squared, no matter what numbers are added, subtracted, or multiplied, the graph is going to create a parabola, is what we call it, shape, which if you're like, what is that? It's basically a U, or it could be an upside down U. All right, We've done two of the equations together. Let's see if you can identify the graph of the next equation. This one's an absolute value equation. See if you can plot enough points to determine the shape of the graph. On your own, go ahead and try this. I'll be walking around. If you are unsure about how to plug in the points, or if you're confused, let me know. I'll run straight to you. But go ahead and see if you can create this graph. All right, guys, is this one creating a U shape? No, how does it differ? A V shape. Now, wait, real quick. What if I had not put the numbers 1 and 2 and I didn't have those points and I just said, oh, this looks like a line, so I'm going to draw it as a line? Would I be correct? No. So the key is you want to make sure you have enough points until you get the true shape of the graph. Tonight's homework will only have these 4 types of equations, so you should know what shape you're looking for, but you want to keep going until you know the shape that should arise is actually coming on the XY coordinate plane. If you're not getting a shape, most likely you're doing your algebra wrong in your table. So make sure to kind of look at that as you're moving through. Okay, the key for the absolute value graph is the graph is going to create a V shape. It could be facing up. It could be facing upside down. Okay, last graph we look at today is the square root. Y equals the square root of X. So in the same way that we did before, create the table. And I told you that these points were pretty good for today, -2, -1, 0, 1, and 2. Let's take a look at how they work with this equation. If I plug in -2, I would have the square root of -2. That's imaginary, so it would be I root 2. And I'm not sure if you guys know this coming into Algebra 2, but the XY coordinate plane only graphs real number values. So if you're getting an imaginary answer, we cannot graph that. Now, if you move on to pre-calculus, you will learn about a complex plane, which you can graph imaginary numbers. But for Algebra 2, you can only graph real numbers on the XY coordinate plane. Well, that's true in pre-calculus too. If you have the XY coordinate plane, there's no imaginary numbers that can be graphed. So if you didn't know that, let's just go ahead and write it. You cannot graph imaginary numbers on the XY plane. Okay, so if that's true, I wouldn't want to start with numbers like -2 and -1. What number would I actually want to start with? Positives. Is 0, can we do 0? Yeah, 0, actually, you could look at it as a positive. What is the square root of 0? 0. We can plot that point, 0, 0. Could I plug in 1? What's the square root of 1? 1, so we'd have the point 1, 1. I could plug in 2. Does anybody know the square root of 2 off the top of their head? 1 point something. I don't know it off the top of my head. So let's just choose something that I don't have to reach for my calculator. 4 would be a good number because what is the square root of 4? 2. Good. So I'd have the point 4, 2. What would be another good number to plug in? 9. Perfect squares are really your friends when you have a square root. So square root of 9 is 3, and I would have the point 93. Could I plug in 16? It would go off my graph, but it is a point. The square root of 16 is 4. So if I was kind of visually showing the reader where that point would be, it would be around there off the graph. But now I know that this graph is going to continue in this direction. And I would just show an arrow to show that's the shape that it will create, or that's the shape that all the solutions will create. We don't really have a name for it. I heard a different math teacher called it a shark fin. I don't know. We call it a square, which is the square root graph. I just think it looks like a swoosh. I don't really know, to be honest. I'm sorry. So you do need to know just that shape. It creates if you want to call it a shark fin or you want to call it a swoosh, you just need to know it creates that shape. All right. So off of those 4 graphs, on next week, Tuesday's quiz, an example of a question you might have is one like the one below, multiple choice. Which of the following graphs could be the graph of an absolute value equation? Turn to your partner and tell them what answer you think this would be. I don't know if you heard that, Olivia. What did you say?
C.
Which one?
C, the third one.
C, yes. Good. All right, guys, I heard it throughout the classroom. It is C. What if I asked you to identify the square root graph? A, good. So make sure you know the difference in the graphs. What if I said identify a quadratic? B, or I could say a parabola. And then D would be what type? Linear if you want to be fancier, but line works too. It's a linear equation. Okay, in all of the above examples, you were given an equation and you had to graph it. The converse would be you're given a graph like the one below, and you have to create the equation that would make the graph. Now, this is one of the really critical thinking parts of math. When you get into higher level math, being able to create an equation, it's one of the most difficult things. But I think you guys could do this one based off of what you learned yesterday. So here we're creating the equation of a circle on the XY coordinate plane. Let me remind you the definition of a circle and then review what we did yesterday to create it. So what is a circle? A circle is the set of all points, like this one here, this XY, whose distance from the center, and if you're looking at the center on this picture, that's HK, whose distance from the center is one number. We call it the radius. So essentially, I could choose any point on this circle, and the distance from that point to this point has to be the same number, has to be the radius. We learned about distance yesterday. So let's just do kind of a recall. In fact, you did it on your bell ringer. How do you find the distance? Find the distance between 2 points on the XY coordinate plane. Distance formula. What is the distance formula? Square root of x2 minus, you could say y2. I think we learned it with y2, but I'm going to stick with x just for this example. x2 minus x1 squared plus quantity y2 minus y1 squared. Okay, if I'm using this picture, the definition of a circle is all the distance from the outside point to the center. So how do we find the distance between the 2 points, HK and XY? Could we just use the distance formula? So you'd use the distance formula. This would be your x1, y1, and this would be your x2, y2. And just as a side note, that's a comma. That's not an x1. So we'd plug that in. We'd plug in x for x2. We'd plug in h for x1. We'd plug in y for y2. And we'd plug in k for k1. And we would have the square root of x minus h squared plus y minus k squared is going to equal, now let's go back to the picture. What did you actually find in terms of the circle if you found the distance between those 2 points? R, you found the radius. Now, if you square both sides of the equation, this is actually the equation for a circle. So I'm going to go ahead and say, now square both sides of the equation and dramatic pause. That will be where we put the equation of the circle. So we would square this side and square this side. And we would get that the radius squared is equal to quantity x minus h squared plus quantity y minus k squared. And the key to know about this equation is that hk has to be the center of the circle and r has to represent the radius. X and y, if you look back at the picture, X, Y represent any point on the outside of the circle. If you're wondering, you could Google it. What's the equation of a circle on the XY coordinate plane? You just found it. It's exactly that. Caroline.
So in the distance formula, is it like the first one plus the second one or not?
Plus. All right, guys. And let's just stop with this example. You don't actually have homework on circles tonight. You will on Thursday night. Tonight's homework is over the XY coordinate plane. So we'll continue here on Thursday. And I will pick a row down.